In this video, we are going to learn about beta and gamma functions and its applications. So now let us start with the definition of beta function. Beta function is defined as beta of m comma n is equal to integral 0 to 1 x power m minus 1 1 minus x the whole power n minus 1 into dx, where m and n are greater than 0. So another form of beta of m comma n is given by 2 times integral 0 to pi by 2 sin to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta. This integral is also called Euler's integral of the first kind. Now let us define what is gamma function. Gamma function is defined by gamma of n is equivalent to integral 0 to infinity e power minus x to the power n minus 1 dx for n greater than 0. This integral is also called Euler's integral of the second kind. It is defined for all positive values of x. And the reduction formula is given by gamma of n plus 1 is equal to n gamma n. From this we can reduce gamma n is equal to gamma of n plus 1 divided by n. So these equations 1 and 2 will give you the complete definition of gamma of n. So another important thing is that gamma of n plus 1 is nothing but n factorial. And two more formulas are needed. Let me write it here. So if you want to evaluate these type of integrals, for example, if you are going to get it like this, you have to remember this like a rule. Integral 0 to pi by 2 sin to the power px cos to the power qx dx is equivalent to gamma of, so this is nothing but gamma of p plus 1 divided by 2 gamma of q plus 1 divided by 2 divided by 2 times of gamma of p plus q plus 2 divided by 2. Same way, if you want to evaluate integral of the form integral 0 to pi by 2 sin to the power nx dx or integral 0 to pi by 2 cos to the power nx dx, this is nothing but gamma of n plus 1 by 2 divided by gamma of n plus 2 divided by 2, this is not square root, it is gamma of into square root of pi divided by 2. Okay, so these are the results that you are supposed to remember. In some cases you will be arriving at these type of things, so you are supposed to remember, right? Then the relation between beta and gamma functions are given by beta of m comma n is equal to gamma m into gamma n divided by gamma of m plus n. Now let us solve a problem. We are supposed to show that gamma n is equal to integral 0 to 1 log of 1 by y to the power n minus 1 into dy for n greater than 0. So by the definition of gamma function, how do you define the gamma function as? Gamma function is defined as gamma of n is equivalent to integral 0 to 1 log of 1 by y. Gamma n is equivalent to integral 0 to infinity e power minus x to the power n minus 1 dx for n greater than 0. So this is the definition of gamma function. Now let us take this e power minus x as y. So what will happen if you are going to take e power minus x as y? When you take log on both sides, this will be minus x is equal to log y and x can be written as minus log y. So by the property log of this will become log y to the power minus 1, or you can write x is equal to log of 1 divided by y. Okay. In the same way, since y is equal to e power minus x, when you differentiate this term, you will get e power minus x into minus 1. So it is minus e power minus x dx will be equivalent to dy, and dx will be equivalent to minus 1 by e power minus x dy, and this is equivalent to 1 by y into dy. E power minus x is nothing but y. Therefore, this is equivalent to minus 1 by y into dy. Now, we are supposed to check the limit. So, what is the limit already given in the problem? So, limit is given as 0 to infinity. So, limit for x is from 0 to infinity according to the definition of gamma function. It is from 0 to infinity. But we are taking the substitution as y is equal to e power minus x. So when x is equal to 0, what will happen? E power 0 will be there. So this will be 1 to e power minus infinity. What is the value of e power minus infinity? It is going to be 0. So the limit will change as 1 to 0. So now we are going to update everything in the definition of gamma function. Therefore, gamma n is equivalent to integral 1 to 0 and e power minus x is nothing but y, and we need x is nothing but log of 1 by y. So this is log 1 by y whole to the power, let me write this as n minus 1, then dx. What is dx? It is minus 1 by y dy. So this is minus 1 by y into dy. So y term will get cancelled and the remaining will be integral 1 to 0. You have a negative sign outside and this is log of 1 by y to the power n minus 1 dy. So by the integral property, you can reverse the integral as 0 to 1, the compensation of minus. So this will become integral 0 to 1 log 1 by y to the power n minus 1 into dy. This is y. Okay. So we have arrived at the result that gamma of n is equivalent to integral 0 to 1 log 1 by y to the power n minus 1 into dy. Right. Now we'll move on to the next thing, that is express the following integral in the form of gamma function. So now when you see here, this is integral 0 to 1 dx by square root of 1 minus x to the power 4. So now we are going to take this x square as sin theta. So by taking this way, you can use the trigonometric identities. So if you take x square equal to sin theta, what will be the value of x? X will be equivalent to sin to the power half theta. So what will be dx when you differentiate this? When you differentiate, you will get 2x dx is equal to differentiation of sin theta is cos theta into d theta. Therefore, 2 dx is nothing but cos theta divided by 2 times of x into d theta. X we have already found. So this is nothing but cos theta divided by 2 into sin to the power half theta into d theta. So this is equivalent to 1 by 2 times of sin to the power minus half. I am just taking this to the numerator. So this will become sin to the power minus half theta into cos theta d theta. So now same way we have to see the limit. So what is the limit for x? It is been given. It is given that x varies from 0 to 1. Now we are converting everything in terms of theta. So we need what is the value of theta now. So how do you find the value of theta? From this part, sin theta equal to x square. So theta will be equivalent to sin inverse of x square. When x takes the value 0, what will happen? X square will also become 0. Sin inverse of 0 is nothing but 0. And when x takes the value as 1, 1 square will be 1. Sin inverse of 1 will give you pi by 2. Therefore, theta varies from 0 to pi by 2. So, this is equivalent to, instead of integral 0 to 1, this becomes integral 0 to pi by 2, and in the instead of dx, this is nothing but 1 by 2 times of. So let me take this 1 by 2 outside. So this will be 1 by 2 times of sin to the power minus 1 by 2 theta into cos theta d theta divided by, we have square root of 1 minus x square. That is square root of 1 minus x power 4 is there. X square is sin theta. So this will be sin square theta. 1 minus sin square theta can be written as cos square theta. So square root of 1 minus cos square theta will give you cos theta. So this is equivalent to 1 by 2 times of integral 0 to pi by 2 sin to the power minus half into theta, and this is cos theta divided by, for this term also you are going to get it as cos theta d theta. So cos term will get cancelled and resulting will be 1 by 2 times of integral 0 to pi by 2 sin to the power minus half theta into d theta. So already I have said we are supposed to use these results in these type of problems. So within the interval 0 to pi by 2, if the function is sin to the power nx dx, then this is equivalent to gamma of n plus 1 divided by 2 divided by gamma of n plus 2 divided by 2 into square root of pi divided by 2. So for this problem, n is nothing but minus half. So this will be equivalent to gamma of minus half plus 1 divided by 2 divided by gamma of minus half plus 2 divided by 2 into root pi by 2. Okay. So let me write it here itself. So this is nothing but gamma of, so minus half plus 1 will give you half. Half divided by 2 is nothing but 1 by 4 and divided by, so here minus 1 by 2 plus 2 will give you 3 by 2. 3 by 2 by 2 will give you 3 divided by 4. So the answer will be gamma of 1 by 4 divided by gamma of 3 by 4 into root 3 by 2. So the solution for the root pi by 2. So this is root pi. So the solution is this. That is gamma of 1 by 4 divided by gamma of 3 by 4 into root pi divided by 2. So now we will move on to the next problem. We are supposed to prove that beta of m comma half is equal to 2 to the power 2m minus 1 into beta of m comma n. Yeah. So now let us start with the left hand side. Before that, we need the definition of beta of m comma n. So we have two definitions for beta of m comma n. So since the power is of 2m minus 1, so we are going to take this definition, that is 2 times integral 0 to pi by 2 sine to the power 2m minus 1 theta and cos to the power 2n minus 1 theta d theta. Let us mark this as equation number 1. So for the left hand side, we need beta of m comma half. So for this purpose, we are going to take n is equal to half in equation number 1. So if you substitute n is equal to half in equation number 1, what will happen? This will be 2 times integral 0 to pi by 2 sine to the power 2m minus 1 theta. What will happen to this term when you replace n by half? 1 minus 1 will become 0, anything power 0 will be 1. So this term is going to become 1. So this is simply d theta. So let us have this as it is. Similar way, now we are going to find what is beta of m comma m. So if you want beta of m comma m, we are supposed to replace n by m in equation 1. Substitute n is equal to m in equation number 1. So this will be equivalent to 2 times of integral 0 to pi by 2. This is sine. Let us combine these two. This will be sine theta into cos theta. So anyway, this is going to be 2m minus 1 and here this power is going to be 2m minus 1. So raised to the power 2m minus 1 into d theta. So we know that 2 sine theta into cos theta is given as sine 2 theta. Therefore, sine theta into cos theta can be written as sine 2 theta divided by 2. So this will be equivalent to 2 times integral 0 to pi by 2. In the place of sine theta into cos theta, it is sine 2 theta divided by 2 raised to the power 2m minus 1 d theta. So this is 2 divided by 2 to the power 2m minus 1. We can take it outside. The remaining is nothing but 0 to pi by 2 sine to the power 2m minus 1 in 2 theta into d theta. So now let us take a substitution. Let 2 theta be equivalent to some other function phi. Therefore, 2 d theta will be equivalent to d phi. So what will happen to the limit? The limit for theta is from 0 to pi by 2. Now we are converting everything in terms of phi. So what will happen to this? Since 2 theta equal to 5, when theta equal to 0, phi will be 0. And when theta is equal to pi by 2, 2 will get cancelled and you will get the value as pi. So phi varies from 0 to pi. So this is equivalent to, this you can write it as 2 by 2 to the power 2m minus 1, and here this is integral 0 to pi, and this is sine phi to the power 2m minus 1, and d theta is nothing but d phi divided by 2. So we can cancel these two and remaining will be 1 by 2 to the power 2m minus 1 integral 0 to pi sine to the power 2m minus 1 into phi d phi. Okay. So this is nothing but beta of m comma m. So you can take the constant to this side. So this is 2 to the power 2m minus 1 into beta of m comma m will be equivalent to integral 0 to pi by 2 sine to the power 2m minus 1 phi d phi. So we have the result, that is, when you come to this part, beta of m comma half is equivalent to 2 times integral 0 to pi by 2 sine to the power 2m minus 1 phi into dt, 2m minus 1 theta into d theta. So this can also be written as 2 times integral 0 to pi by 2 sine to the power 2m minus 1 phi d phi. So everything is equivalent. Therefore, instead of this term, we can replace it by 1 by 2 times of beta m comma half. So this is equivalent to 1 by 2 times of beta m comma half. So this is 2 to the power 2m minus 1 into beta of m comma m. So this will be equivalent to 2 times 2m minus 2 beta of m comma m, which is nothing but beta of m comma half. So we have arrived at the result. So this is this last problem in a beta and gamma functions. Here we are supposed to prove that beta of m comma half is equal to 2 power 2m minus 1 into beta of m comma m. So by seeing the power, we have 2m minus 1. So we are going to use the definition of beta of m comma n in terms of sine and cos. So here, by the definition of beta function, it is beta of m comma n is equivalent to 2 times integral 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 into theta d theta. Let us have this as equation number 1. But we need beta of m comma half. So we are going to replace n is equal to half. So we are going to put n is equal to half in equation number 1. So by doing so, we will be getting the value of beta of m comma half as, this is 2 times integral 0 to pi by 2 sine to the power 2m minus 1 theta. What will happen to this term? When you replace n by half, this will be 1 minus 1, 1 minus 1 will become 0, cos power 0 will become 1. So this term is going to become 1. So this is simply d theta. So let us have this as it is. Let us mark this as equation number 2. Similar way, we need the value of beta of m comma m. Therefore, we are going to put n is equal to m in same equation number 1. So by doing this, we will get the value of beta of m comma m, which is equivalent to 2 times integral 0 to pi by 2. So what will happen if you replace n by m? Here also the power will be 2m minus 1. And for cos also it will be the power 2m minus 1. So we can combine this and write it as sin theta into cos theta to the power 2m minus 1 d theta. So what is cos theta into sin theta? Sin 2 theta is nothing but 2 sin theta into cos theta. Therefore, sin theta into cos theta can be written as sin 2 theta divided by 2. Okay. So let us consider the last equation, that is beta of m comma m is equivalent to 2 times integral 0 to pi by 2. In the place of sin theta into cos theta, we are going to replace it by sin 2 theta divided by 2 to the power 2m minus 1 d theta. So this will be equivalent to 2 divided by, let us bring this 2 to the power m minus 1 outside. So this will be 2 to the power 2m minus 1, and the remaining will be 0 to pi by 2 sin 2 theta to the power 2m minus 1 into d theta. So let us take, so this is a power, let me write this again. So this is sin to the power 2m minus 1. So let us take a substitution, 2 theta equal to some other function phi. Therefore, 2 d theta will become d phi and d theta will be d phi divided by 2. And what will happen to the limit? Limit for theta is from 0 to phi divided by 2. Now we have converted everything in terms of phi. So we need to find the limit for phi. So what will happen when theta equal to 0? What will happen to phi? Phi will also become 0. Same way, when theta equal to pi by 2, 2 and 2 will get cancelled and you will get the value as pi. Therefore, this is equivalent to 2 divided by 2 to the power 2m minus 1 integral 0 to pi. Instead of pi by 2, it is 0 to pi sin to the power 2m minus 1. 2 theta is nothing but phi, d theta is nothing but d phi divided by 2. So you can cancel out the 2. Therefore, this will be equivalent to 1 by 2 to the power 2m minus 1. This is integral 0 to pi sine to the power 2m minus 1 into phi d phi. So this is also equivalent to 1 by 2 to the power 2m minus 1, 2 times of integral 0 to pi by 2 sine to the power 2m minus 1 phi into d phi. So now already have the result. So this you can also write as 2 times integral 0 to pi by 2 sine to the power 2m minus 1 into phi d phi, both are same. So in the place of this term, we can replace it by beta of m comma half. Therefore, this is equivalent to 1 by 2 to the power 2m minus 1. By using equation number 2, you can write it as beta of m comma half. So this is nothing but beta of m comma m is equal to this term, or this is equivalent to 2 to the power 2m minus 1 into beta of m comma m is equivalent to beta of m comma half. So we have proved that this is equivalent to this term. Okay. So thank you.